Okay, second lecture for today. Now we'll try to see a bit how to manage all your projects, the website, but also the project files and so on. There are many different ways. I won't go deep into all of them because also Neil is going to explain you all of them. I will explain one specifically because that's what we are going to use here for at least for the first weeks and months, and then we will see if we switch to another one. Let's see, I can show you also these slides that I've been using in the course of Interaction Design, in the Master Interaction Design at SUPSI in Lugano, in Switzerland. My course is about design with the user, so doing open design and collaborating in the design process. And then if you go here to supsi.openpeertopeerdesign.org, then you go to this year's course. There is this course about version control systems. So there is much more that you actually need, but at least you can get a reference of all the commands and things and how to install them. Okay. So we'll see basically version control system, and more specifically we will see Git. I won't follow the whole structure of the lecture, but more or less we go here. Yep. The website is supsi.openpeertopeerdesign.org. I will send you the link with the email. Yeah. See, there are also slides are in HTML and JavaScript. Okay. Well, I'll just make you an example how it works usually in big projects. So, well, if you want to see, if you want to read, this is a book that you can download from the web about how usually open source projects are structured. But I will show a bit of what's actually could be possible with a real life example, and then we will go deeper into the practice. So to take an example, this is the RepRap, an open source 3D printer, where actually some part of it can be reprinted by the printer itself. We will focus on this part, which is a spool for the filament, for the plastic filament, which is not part of the RepRap, but it's a separate project. So I took it from Thingiverse, which is a website where you can upload 3D models. And there is also a basic way for having collaborative process, but very basic. We are going to use something that's much more advanced. So the first user created this object, okay? A second user created a more advanced structure, more robust structure here, starting from the first design. Then another user subdivided it into 4 elements, so it's easier to print it because it's smaller. And basically that's the idea of having different versions of the same project. Okay. So now historically, most of the version control system had a more central structure. The idea is that you have a central repository where everybody connects to with their own computer, so everything is stored here in the database. So somebody send the files here, so in this case Carl, and then the other download them. And that's the same for the other files, okay? Bob send the files and the other need to download them. So in the end, that's the result, okay? You can integrate the input from the other people. So one of the most interesting is Subversion, in this case, which is open source. You have 3 books about Subversion. Now the problem usually is when you have more people working together. If you download the files, somebody modify and upload, then when you want to modify the files, the repository will tell you that there is a mismatch. Okay, so how do you solve this? So one of the first things historically was to lock it. So you're working on the file index, you download it, you say to the repository lock it, so nobody else can modify it, and when you're over with it, you upload it and you unlock it. The problem with it is if you take months to finish it or you go on holiday, then nobody else can work on that. Okay. So the idea that was created, especially with Subversion, was that when you do this thing of uploading and unloading, then you get the error, okay, of a mismatch. And the idea is that basically you can see which are the differences between the 2 files. Then you have to merge them, okay. So you pick this file, the other file, you decide which one is the best one, you merge and then you upload it. So that's still basic and you can still use it. And that's just for the historical version. I'm covering Git because we are going to use Git at least for the first weeks. The main part of the Hub Academy use Mercurial, which is very similar. They're very similar within the command, with the structure. Of course, they have differences, but we start with Git for many reasons. The first is that we were going to use GitHub as a website for managing the repository because it has a lot of features which are very nice. And then if you are familiar with this and you're okay, then we can move to Mercurial later. So the other problem is that in this way we have a safe pool where we can work together. We are 11 here. We can work together on that, and it's easier because otherwise you will be with almost 100 students. So if you have any problem with that scale much more. Okay, Git. You can download Git from git.smn.com. So this is the website. We are going to use the Git from the terminal, from the command line, which is this one. Okay. In Mac you can find it in Applications, Utilities, Terminal. In Linux you should know where it is. You should just choose Terminal, and then I will explain how to do that in Windows. The reason we are using the terminal is that Git was designed for the terminal. If you go and look for instructions, tutorial, books, and so on about Git, you will find only instruction for the terminal. And you need the terminal for understanding how to use it, because the graphical user interfaces are a bit more complex. So when you know how to use Git from the terminal, you can move to the graphical user interface, in my view. So we are going to use it from the terminal. So you download it here for Mac or Windows. In Linux, you should be able to download it from your own software center. Yeah, usually it's git-core on Debian. If you install it on Windows, when you install it, you will be prompted with this image. You need to check this use git bash only. So basically, this installs a specific terminal that works in a Unix-like way. If you install this, that's basically it works in the same way in Mac, Windows, and Linux. So just do this because I will explain in the Unix way. So if you don't do this, there are going to be differences.
They have to install it on the computer. But I don't remember if I installed this one. So I installed it so in order to follow.
Yeah, usually with the computer, rebooting or installing is the best solution to. Well, I'm going fast with this, but you can find a lot of videos online. Okay, now about the structure. First, historically, Git is interesting because it was developed by Linus Torvalds himself for the development of Linux. So the idea with Git is that you can actually use it for very big projects like the Linux kernel. So it fits for us, for 11, 12 people. So if it works for hundreds of people, dozens of people, it works for us. The interesting thing that when it was designed around 2005, and of course still developing, the idea was to change the architecture, and it has what is called a distributed architecture, and Mercurial has the same. That means that you can have many more repositories, online repositories, but also that everybody has its own local repository. So all the history is stored locally and remotely, usually used remotely for synchronization or for backup. But if you are offline, you can still work with your computer. With Subversion, if you are offline, you cannot work with the history, because the history is always online. Okay. Then of course this is like a bit of extreme setup, because most of the time you will have just one central repository. But with a bit of work, you can do these kind of things. You can even use different protocols for exchanging files over Git, so you can also work on a peer-to-peer level with another computer. Okay, so you can communicate without another server. So for example, this person uploads something here, that's a backup, or something in the others repository, and this as well. Then of course the other, they need to synchronize as well, and then with the other files as well. So in the end, you can get something like this. This is a bit more extreme. I mean, you can do it. It's a bit complicated, but you can do it. Usually, you will have probably one just central repository, and you have to synchronize all the files between what you send and download. Okay, but just to explain it, that with this you can really do a lot of different things. So on the Git website, you have this book, which is for free. It's ProGit, so it's a very good reference for using Git. This is a book that you have to buy, unfortunately. It's a bit more advanced, but it's very nice. So if you find ProGit is not enough for you, then you can move to this. This is a very nice guide about Git. So it's a very simple guide for using it. There are many tutorials. I'm just showing you some of them, then you go on the link and you can check them. This is interesting because basically it's an interactive visualization of the Git structure. So if you click on these different parts of the page, you understand which are the commands.
Is this a file or
It's online. So for example, if I click on this, I understand which are the commands. I will explain what these things are later. But this is just for you to understand that if you want to understand how to work with this is an interactive way of working, understanding how to work with Git. Okay. So the interesting thing about version control system is that they store information through time. So they're basically a time machine. Some of them, like Subversion, they store the differences in the files. Okay, so in each version they have the difference, the delta from the previous file. Git is different. It's, in my view, a bit better. They actually store the old file in that moment in time. So you can always go back and forward in time with that file. So that's also easier to deal with the files as well. That also means that if you put one file that is like 10 megabytes and then you modify and you save it, then your file size of the repository is going to be 10 and 10 and 10 megabytes added. So you also want to try to work with not very heavy files, especially because we are working with a website for the Fab. Okay.
but if you upload once a big file and you don't change it with a different time, it remains only that file, no?
Yeah.
Every time a different code.
No. In Git, basically, it's stored the file only when you have a difference. If it's not difference, it tells you that it's okay. We are just pointing to that place. No, okay. So here A1 is just a reference to A1. Okay, because the problem is that if you put the 10 megabyte files here, it stays in the memory. Okay, so if you put 200 files of 10 megabytes, even if you then reduce the file size, you still have those in the memory. So one of the difference between Git and Mercurial is that in Mercurial the history is secret, so it always stays there. It always stays the same. You cannot modify the history. In Git you can do that. I'm not going to explain you that because that's also something that could be potentially dangerous when you work with other people because there could be a huge mismatch between the projects. Just to let you know that there could be some modification in the history in Git. But normally you don't want, for example, to put your passwords on GitHub or Git because it stays in the memory, so if it's public then somebody can access it. Okay, so be careful about what you put there for the size, for the information and so on. The interesting thing that really you can basically manage your folder where you have the Git project as a time machine. You will see later that it's really like a time machine. Now the most important thing about Git, or probably the most difficult thing about Git, is that they have some sort of virtual spaces, okay, or virtual steps, which are not very understandable at the beginning. Once you understand them, it's much easier. You have your working directory where you have the files, and if you want to save that version of the file into the history, into the repository, you have to tell Git to save those files. Okay. In order to save this file, you have to basically tell Git how to do that. that you want to add those files, and the idea is that you add them to one area called staging area or index. So it's like a virtual space, and then from there you save it to the repository, to the database. And you can go from one to the other and so on. It's a bit complicated because it's not like, okay, I'm saving the file, but you have to say, I'm working with the file, you save the file, you want to add this to the repository, and then you save it to the repository. Okay, it's a bit not very clear at the beginning. If you want to have an example, just take one airport. Okay, you go to the airport because you want to take a plane and so on. Okay, the working directory is the airport, so it's full of people. Okay, then they will call you to go to the gate in order to go on the plane, and the gate is basically the index. And when then from the gate they let you board the plane, that's the repository. Okay. This also means that there are different file status in the whole life of a file. So when you have the file, Git is not tracking it. You have to tell Git, okay, track its history, track its differences, because Git automatically understands if the file has changed. Then when it's tracked, then it could be unmodified. If you modify it, it will tell you, and stages when it's in the index. Okay, well, here the terminal. I usually drop it here so it's easier to access it. In Windows, it's this Git bash. Okay. But before we use Git, we need to work a bit with the terminal. Okay, so this is the Unix command line for the terminal. I will show you, for example, this is the document. Okay. And here. So the first command, if you want to understand where you are, it's print working directory, so it's pwd, and it will tell you where you are. So if you don't remember where you are, that's a good way for remembering that. No. The terminal is just another way for browsing files. Okay. Usually it starts with the home, but maybe sometimes you're working and you don't remember where you are. If you print pwd, print working directory, it tells you where you are. Okay? And for example, you change the directory with cd, change directory, and the name. So in this case, I want to go into documents. So document starts with the uppercase D. There is a difference between uppercase and lowercase, remember? And I could write documents. Then there is one trick that saved my life when I realized it, that if you press tab, it will autocomplete it for you. If you have more than one file or folder with the same beginning letters, it won't do anything. So if I do C, at the second time it told me, yeah, you have desktop, documents, downloads, and Dropbox. Which one? So for example, documents. So I can do doc, because it's already different. And then if I press tab, I get documents. Okay. If I do, for example, DOW, D-O-W, if I press it, it's download, because the name changed at that third characters. So for example, documents, and press enter, you go there. So for example, here I'm in documents. If you want to go back to the parent folder, it's D space period.
It's like this of those.
Yeah. But if you on Git bash, you're going to use this. You're not going to use the DOS command.
What is the command to change the upper layer?
CD and space period. So I go to documents, for example. If you want to understand which are the files and folder, the command is ls, as in list. So ls, and you see all the files that I have. So one thing more about the terminal is that you can do like in the browser. If you do Command T, you open a new tab. Command N, you open a new terminal. So you can have much more. Okay. You can scale it and so on. The interesting thing that you see, okay, I already have a lot of output here. So if I want to clear a bit the screen, the command is clear. If I go up, I still have them in the history, okay? But it's just cleared temporarily. If you press the key up and down, you can go up and down into the history of the commands that you created. So if you need to redo the same commands up again and again, okay? So ls will give you a list, but you don't understand which are the files, which are the folders, and you don't see which are the hidden folders, hidden files. So usually you will do ls space la, and then you see the permissions, the user, the group, the file size, the date, and the file name. All the files that starts with a period, with a dot, these are hidden. Okay, so these are hidden files or directories. Okay. Let's say, for example, if you see, I have this folder called GitHub. All the projects that I have on GitHub are there. So I go to the GitHub. Again, if I do ls-la, you see I have all of these different projects, which is basically here. I go in GitHub, and these are all the projects. Okay, so it's exactly the same. I'm just accessing it with a different tool. Okay, the terminal is it's a bit more difficult to understand at the beginning, but then it's much faster. And then you see things like the hidden files that it's much more faster. Okay. So now we have more commands to work with the files. So for example, if I want to create a directory, you have to do mkdir, make directory, and the name. So for example, mkdir tab academy. Okay. Now I can go in cd tab academy. If I do this, it's user massimo document tab and tab academy. Yeah, I created it and now it's there. So you see here now it's this one. There is nothing inside. If I want to delete it, is rm, as in remove. Since it's a folder, you need to do r recursively the folder. Now if you go here, it's gone. rm is also for the files. You just don't go recursively. So for example, if you want to create an empty file, you just do touch file name.txt, for example. And now I have this file name.txt, okay, which is 0 bytes, it's empty. If I want to delete this rm file name, in this case I can press tab and I get the autocomplete. I delete it and it's over. It's off. It's gone. -r is for going recursively inside the folder. So if you try to remove a folder that has some content, it will tell you I cannot because there is content inside. So if you do remove -r, it's like, okay, remove everything that's inside. Okay. If you have some problem with permission, it will ask you, do you want to remove it or not? So the quick way and the dangerous way is rf, so force. So you do rm-rf direct. But when you do this, then it's gone. When you use remove, it doesn't go to the trash can. It's gone forever. Okay? The other thing that you want to do, for example, if you create the file, is move it. Moving or renaming a file is the same because you're moving to a different position. And the command is move md, file name, new file name or new position. So for example, I call it from file name to file name 01. Okay, so here's the file. And now you see here is 01. If you want to copy, it's the same. It's cp as in copy, file name, and where. Okay, if you want to copy as a separate file or in a separate folder, you just write it. If it's a folder, you need to finish with a slash. Okay.
You just need the name of the folder or the entire path?
No, you can do both. For example, I create a folder called Fab Academy. Okay. Now I want to copy file name. See, with a tab, it goes automatically into Fab Academy. It goes automatically. You have the slash, that means let's go to the folder. I copy it. If I go to Fab Academy, here is the file.
Fab Academy destination?
Yeah. You could also do, for example, cp file name 01, file name 02.txt, and basically it will copy as another file, but with a different name. So it's just taking what, where. Okay. Of course, if you want to move or rename it, it's move. Copy, just copy it. It's not necessary that you use this. You can work from your file explorer, but as you will see, that's also important for Git, because we have to use something similar. Is everything okay so far? Okay, if you install Git, the first thing that you need to do, you have to configure it. You have to tell Git who you are, what's your email, and if you want to add more things, so on. Because everything that you do, Git save your information with that thing. So you can always know who did what, when, and why. And then if it's needed, you can contact them. So the first thing you need to do is to add your name, which usually is name and surname. And this is the command. So the command is git config -- global user.name and between quotes your name. This is a string, so you can write whatever you want. You do it from the terminal, wherever you are. Okay, where you are because you have Git installed in all your operating system. You can change this information on each project, but you will probably not do it for a long time. So it's git config -- global mean for your operating system, user.name, in my case is Massimo. Okay, and then you press enter, and it doesn't tell you anything.
Okay.
Yeah. The important thing is on the terminal that no news is good news. If it says something, usually it's because there was a problem.
Okay.
Then you will see in Git some command, they will give you an output, so they will tell you what happened. But if you don't see anything, it's okay. Okay. The second thing is the email. So it's git config -- global. This is user.email, and here is your email. So now I know that every time that I save something, it will tell you that Massimo Minchinelli, which can be reached with this email, did this. So that's a good way for understanding who did what and to contact people. Okay. One more thing that you can do, you can add these settings, which will really copy and paste, which is git config -- global color.ue auto. which add a bit of colors to the output of Git in the terminal. So it's a bit nicer to use it. And here again you paste it. You may probably get a problem with the version.
Quindi cazzo.
Okay, when you get this, that means
Si sfaggi da questo.
No, ok, no, dico dopo questo. Perché ti cambia?
Tell you
Cazzo sì.
it's not global, it's
Teoricamente non
global.
avrebbe cambiato
Che non sono la
So
cartella.
usually when you get this install or command means that
Non lo so.
tells you here. Now let's make
Home
this here.
folder. You want to be in your folder?
No, in Git folder.
Wherever you are, you
Wherever
can do
you
this.
are.
Wherever you are.
Git is a global command.
Yeah. This is a global configuration. For the local, you need to be in the project, but you don't want to do this now.
Ok.
Don't worry. This is something that you will have to do also in Mercurial as well, because you need to be able to identify yourself and what to do. Is it okay so far?
There is a command to verify the username email or
Yes, I don't remember. So usually you look for git show configuration. And usually it's git config dash list. So if you do here, you see the configuration.
okay.
So you don't need to remember all the commands in Git because there are so many. You need to understand how to look for them on Google.
Git config fate trattino list e tu fai sì, è tutto
Massimo, the last command, the one with what is it about?
When you work with Git and will give you an output, if you don't do it, it will do everything in the same color.
Windows era diverso.
So with that, it will add some bit of color, not too much, because we are still serious people. But it will help you a bit more to understand the output. So that's something I discovered, and it's pretty useful.
It's normal that in your Windows, when you make config list, it tells you
Beh, guarda.
a lot of information and
No,
It depends on your
guarda.
computer.
okay.
It depends on your configuration. So I have something more. For example, I have these things more that you can find in my slides how to install. I will show you it later. Otherwise, you will probably have like just 2 things.
Because I have 4 starts of color and
So one thing more that you will probably can do it later, but I will just show you that you will need a tool for comparing the different versions of the files. We will see how to do this in GitHub, which is a bit more easier. But you can do also on the desktop. Git will, by default, give you the difference between the comparison between the files by text. But if you want to have also the images, the easiest thing is that you install this software called P4Merge, which is for Windows, Mac, and Linux. It's not open source; it's freeware. It's for Perforce. Perforce is another version control system. We don't use that. You just have to install this Visual Merge and Diff tools. The link is here, so you can do it later. The interesting thing, okay, this is the link. And you just need the P4Merge. You don't need all the others. We don't go deep into that, but if you want to use it, then you need to configure it. And then by configure it, you need just to copy and paste each of these lines in your terminal. This is for Mac, and then later there is for Windows. Okay, so if you want to use this later, maybe I will show you how it works. We won't spend time on checking this on this computer, otherwise the lecture will be very long. But just to show you that there is information online for using this. Okay. So we'll just go back into using Git. I will modify a bit the history of the lecture, so not what's there, because I want to save a bit more of time. So if you remember this, there was the idea of having working directory, the index, and the repository. So the airport, the gate, and the plane. But then, of course, you want to go to another city. Okay? That's the remote repository. So you are in the airport. Some few selected people go to the gate, the index, or staging area. And then they go on the plane, the local repository, and then they go to the remote repository. In our case, the remote repository is for synchronize our work together. So you can do very complicated stuff. But by default, you can use Git just with the local repository. So we'll always have the history of your projects locally, but then at least you get the remote repository for backup. And GitHub basically is the remote repository with a very nice software interface for that. If you want to go to these images again later in the future, it's also synthesis of the commands that you will need to use, but we will see later. Okay, I will explain you a bit, okay, let's try to do this. There are two ways for starting a Git repository. Okay, one is from your computer, the other one is from GitHub. It's easier for us if we do it from GitHub. Okay, so you have to go to github.com and register for a free open source account. So everything that you will do will be public, but you can use it for free. So in this case, I've already logged in, so I can see here all my repositories and all the new events that happened in my network of people or projects I'm following. And you can create a new repository here or from here. So usually you do the easiest thing, and we're going to use the easiest thing, is by creating it here. You can do now your own repository for testing Git and GitHub, but then you're going to use another repository they already created for you. So you create a new repository, you have to choose a name. So okay, you can add a description. This is the URL also for the repository, so you don't want to put spaces. Okay. You need to put public, otherwise if you put private it will ask you for money.
Yep.
Okay, so put public. Then this is very important, it's very simple. It will basically create the repository with a README file. That's going to save you a lot of time and more instructions. So if you do it, repository do with this. So you initialize with this, and then you can do two more things. One on the right, you choose a license for your project. So these are only software licenses. Okay. So if you want to put Creative Commons, then we will put it later. Okay. But if you already know that you want to do something in GPL version 2.0, you just click this and they will create the file for you. Just know. The other file is .gitignore. It's something that we're not going to do now. .gitignore is a hidden file. It's a hidden text file. It's hidden because it's .gitignore. Basically, everything that you saved here, all the files that we saved there, Git will forget about them. So if you don't want to save all the exe files, you edit it, and you put asterisk point exe files. So every time that you have an exe files, Git it's not going to consider it. And then it's easier for you because, for example, you don't want to have the .ds_store files in Mac. But it's not a problem for the moment. Just know that if you click on this, you can choose which one you don't want. Okay. So just public and initialize with the readme. You create it. You can access it to the github.com / your username / the URL. So that's the URL. That's the description that you can still edit. You can also add a website if you want. Here you have your files. In this case, you have this readme.md. And here below, you see the readme.md that's rendered as HTML. This is interesting because everything that you put inside the readme.md is going to be rendered here automatically. The readme.md MD stands for Markdown. Markdown is a simplified HTML. So you can write simplified HTML, or you can write also HTML inside it. Okay, and it is going to be shown here. And this is going to happen in any folder that you create here. So if you create a folder here inside and there is a readme.md, when you go inside the folder, the readme.md is going to be shown automatically on GitHub. So that's simple, but it's a very nice way of having an interface for the visitors on your GitHub. Okay. Now we have many things that we will see later. The important thing is that you see there is here this HTTPS clone URL. You click on this, and this is going to copy the link to your Git repository. You go to your GitHub folder. You do git clone, and you copy and you paste the link. In Git Bash, it's insert. In Windows, it's insert. Function insert.
CD space. You have a folder. Yes.
So if you go enter, then basically you will download what's from GitHub.
Create
Yeah. You will create a directory from the name of the project.
space. Like the test folder. It's not important.
So in this case, it told me that it's cloning it into Fab Academy test. So if I go here, it's Fab Academy test, and inside I have the readme.md. Okay? It's not copying just the files, it's copying all the history that's been saved in Git. So even if you jump in the project that's been going on for years, you will just take a lot of time for downloading, but then you have everything on your computer. That's because Git or Mercurial, they are distributed, in the sense that their database is distributed. So in this case, I enter into the folder, test. I'm in user, Massimo documents, GitHub, Academy test. If I do a list, I have the readme.md. If I do list -la, in order to see also the hidden files, okay, you have readme.md. This is something that you're going to see in any folder, so don't worry. You will see this. This is .git. This is a folder which is hidden, and basically your local repository is inside that folder. If you delete that folder, you lose all the history. So just to let you know that if you see that folder, you say, what is this? I want to get rid of this, then you get rid of all your history. It's hidden. So you see here, you don't see it. You just see it with this. So usually you don't want to touch this. You just let it go. Okay? So now, for example, I edit this MD. You can edit with any kind of software because it's just a text file. I downloaded this, which is called Markdown, which is an open source software for editing Markdown, but you can use brackets. Okay, it just opened actually. The interesting thing about Markdown that you write it in Markdown here and you see it rendered here. So for example, if I want to add another heading,
l'applicazione lì. Non so se ci sono non rispetti.
this is the same as doing, okay, it is exactly the same because basically it's just a simplified renderer of HTML. So if you don't want to learn Markdown,
Windows or
you will find similar softwares. You can use brackets, it's okay.
okay.
This is just because by default was opened by my computer, but you can open it with brackets. Okay. So in this case, okay, I save it. Now there is one command that you're going to use all the time. It's a command for understanding what's the situation. Okay, and it's git status. Status. The same is in Mercurial. You can have AG, which is Mercurial status, and it will tell you the situation. Mercurial is simpler than this, but works the same. So it tells you a lot of things. The first is that we are on branch master. Branches are basically alternate timelines in your repository. So you can have more than one timeline in your repository. We are not going to use that. Okay, just to know that if you are here you can choose the branches. But it's a bit more complicated, so we're not going to use it. Maybe later, not now. The other thing that tells us that basically your local branch is updated with origin master. Origin is the remote repository. When you clone, there is one remote repository called origin, which is where you clone from. You can have more remotes, you can rename the origin, but origin is always there. So we know that everything here is up to date with what's online. Okay? But then it tells us that there are changes that have not been staged for commit. Changes that have not been added to the index or staging area. And this is the file that has been modified. If you see here now it's red, that's the configuration I told you. Okay, otherwise it will be green or black and you don't see the difference. One nice thing about Git that it also tells you what to do. So if you want to add this, is git add the file name, or if you want to release it, it's this, but we'll see it later. So in order to tell Git save this file, we need to add it to the index and then do the commit. You add it to the index with git add and the name. So again, you can do readme. You can also do period, and that's going to add all the files. So that might be dangerous. Okay. So in this case, it's readme. No news. It's a good news. If I do git status, you see we are on branch master. Your branch is up to date. Okay. And tells us changes to be committed. And this is now green. It's a different green if you see it. This is modifying. It's already in the index. So we can add more files. We can wait days and so on, or we can save it into the memory. You can add more files at the same time for saving it to the memory. That would be the idea if it as a logic. Okay. If you want to save it, you need now to do the commit. The commit is the verb to saving it in the repository, but it's also the item in the history. So if you go here, you see there is one commit. If you click here and commit, you will see the history. That's the initial one. Okay. That's basic when you create it, so you will always have the initial commit. If you want to commit, is git commit, and then we have a difference with that. It's important. With that, you need to specify which files are going to be added. You don't add folders. You add the files, and the folders get added automatically. So, if you add the files inside the folder, then also the folders is added automatically. And you have to specify the file name. But then in the stage area, in the index, you have already specified the file name, so you don't have to do git commit file name. When you do git commit, it takes everything that is in the staging area. What you have to do is that you need to leave a message to explain what happened at moment in time. That's very important because you're not going to remember what you did 3 years ago. We don't know what you did 5 minutes ago. So that's a message that you need to write for explaining what you did. You need to do it. If you don't do it, Git will open a text editor for you, and it's not very easy to use it. So the best thing is that you learn how to do the commit. So it's git commit -m as in message, space, and here inside the quote you write a string. You write a sentence explaining what you did. So in this case I put modify readme.md. Okay? You can write a bit more, it depends on what you did. I can add modify readme with headings. Sì, posso. So if I do this now, it will tell me that in master, with modify readme.md headings, there was one file changed, 8 insertions. 8 insertions mean that 8 lines were added with this modification. If I do git status now, we are on branch master. Your local branch is ahead of origin master by 1 commit. Nothing to commit, working directory clean, because we already saved all the modifications. Okay? This is interesting. This git push will basically send this commit to the remote repository. I can do it now, I can do it in 3 years. Then if I do it in 3 years, it will take all the commits and send them at once. So probably you want to do now. But if you're on a train, you don't have a connection, you can do a lot of commits, and then when you get home, you do the push. Okay? So in this case, I do git push origin. I could do origin master. But master is default, and origin is also default. So if I do git push, it's okay. If you want just to take, to get used to this, is git push origin. This is easy because there was a very small modification. In your computer, it's going to ask you for username and password for GitHub. Usually with the Mac, it should then store locally the credentials, or you can find tutorials on how to do that. Otherwise, each time you have to type it. Okay? If I do git status, we are still on branch master. Your branch is up to date with origin master. Nothing to commit, working directory clear. If I go here and I refresh this, I have another commit. Okay, this was done by me, when, the day, and so on. If I go back here to the home page, this is the README, and this is the content that is rendered automatically. If I go here and I click on this, I will see the file. If I click on raw, I will see the raw content of the file, so just the text. That's useful if you want a direct link to the file. Okay. So here you see the history. There are 2 ways for seeing the history. You can see the local history and the remote history because maybe they're not the same. Here it's a very good way for seeing this. If you click on this, you will go back in time in that moment, okay, and you will browse the content of the folder in that moment in time. So if I go here, see, this is the original text.
You can choose what to download.
Yeah, you can download it from here, so you can always access things from here. If you click on this, it will show you the differences with the previous version. So you see that this was the part that was already present, and these were the 8 lines that were added. Okay? You can also see the diff in this way with the rendering, because it's marked down. But if you just get this, you are used to see the code, which you're going to use a lot in Thought Academy. Okay? Then there is one interesting thing. You see here there is this code. That's something that's a bit difficult to understand with Git, but it's very important. Every commit is identified by this code. It is an hash code. It is this strange list of characters because it's also basically a check of the quality of the commit. So it does a technical meaning. The important thing for us is that this code identifies this commit done by this person in this repository in time. There is no way that you can get this code and it points to another repository because the probabilities for these are huge. You see here, these are only some characters. If you copy on this, it will copy this. Okay? If I paste it, if you see that it's much longer. So the full hash code is longer. But if you already take the first 7 letters, then it's okay. They are already enough for identifying that commit. That's important because you can use it for going back in time on your computer. You can use it for going back in time from your computer. So how do you say the history on your computer? There are 2 ways. One is with git log. You see, for example, this is from the last, okay, to the previous. So you always get the latest at the top. You see the commit as this hash code. So this is identified by this. I did it. This is my name and surname taken from the configuration. When I did it and the message. Okay. When you do this with a very long history, then you will have to press Q for quit, for going outside of this. The other thing that you can use is a small program that's inside Git that will open up a new window where you can see it in a bit better way. And it's called Git-K. Okay, this is Git-K. You see the commits. You see who did it, when. Here is the hash code. Here you see the difference in text. So this is how you see the history on your local computer. And this is easier than git log.
Yes.
You need to be inside the folder of the project. Okay. Now, for example, this is okay. Why this is useful? Let's make one example. I want to take back one file from the past. You do like this. You copy this. So I want to take back this file from here. And if I do, for example, the command is git checkout. Git checkout has a lot of different usage. Okay, you can use it for move from one branch to the other. I will show you just how to use it for getting a file from a previous version. So in git checkout, you paste the hash code and the file name. So in this case, readme.md. This is basically take that version back in time, okay, and overwrite to the current one with that back in time. So if I do this,
To write the name of the file
Yeah,
after the...
after.
Okay.
So for example, if I open it again, see, that's the previous version. Okay. And if I do git status, of course, it tells me that This has been modified. It's already added to the index when you do the git checkout. So if I want to save it, I need to do git commit -m and the message.
This checkout made a copy on your terminal of this file back in time.
Yeah, not just in the terminal, in your file system. Okay, so if you look on the terminal or if you look here, this is the previous version. So you see, we don't have the. If you go here, still see we don't have this,
Okay.
which was added with the second commit.
It didn't modify the GitHub.
Not yet,
No.
because you need to
It's
push.
new to push. Okay.
So for example, now if I want to commit this, I just do git commit -m modify file. If I don't want to save it, here's the command: is git reset head. Head means the latest part, and the file name, so readme.md. If I do this, it's unstaged. Or if I do git status, it tells me it's been modified, but it's not in the index yet. So that's, for example, when you add some files, but then you don't want to save them in the commit. So how do you do them of the git head? It's git reset head. So in this case, I want to save it. So it's git add readme.md. So git status, you see, is still green again. Now I do git commit -m revert to first commit. Okay, now it's 8 deletions because by going back in time I deleted 8 lines in the text. Okay, if I do git status, we are on branch master. Your branch is ahead of the origin master by 1 commit. Use git push. So if I go here, for example, you see there is still 2 of them. If I do git push, and now I refresh this, I have it. So you save it when you want to have it in the memory. So not necessarily every 2 minutes. It depends on what you did. The interesting thing, again, if I click on here, I go back in time in that moment, I can still access the information.
Git reset head eliminated the file from the commit.
From the index. Yeah.
So if you eliminate from the index, you will push.
If you eliminate from the index, when you commit, it's not going to be saved in the repository. And then the push is just taking the commit to the lower remote repository. Okay. So this is interesting because then you see the history of the project and we understand what one did. It's important because we are working on the same repository, so I want to understand what you did and so on. Okay. Again, every time that you save a new file. So again, don't want to save too heavy files. Okay, too big size. Too big. Now, for example, I will add an image. So, for example, let's see if I can. I save this image. Okay, now I have it. It's here. Now it's clear. If I do git status, this is untracked because it's a new file. Okay, so I need to do git add monitor Mac git commit -m add monitor image, and I need to do git push. If I open it here, I have the monitor image. If I click on this, I can see the image. If I click on raw, I get the link to the image on GitHub. If I go now to for commits, I see here the difference is that one image was added. Now I will modify the image just to show you how it works. So I will use GIMP, which is the open source alternative to Photoshop. Okay. Okay. I will save it, overwriting it. So here, the file is different. If I do git status, Git understand that has been modified. Okay. So if I do git add monitor mac git commit -m modify image and then git push, if I go here, why it's like this? Okay, there was a bug. The nice thing about GitHub, they will show you the difference between the images, not just with the text. So you see the one that was deleted, the one that was added. Okay, you can see them also like this.
You eliminate the shadow under the screen.
Yeah, that's the way they just said because they're PNG, I guess. Okay, so that's a good way about seeing also the difference in the history. One thing more about GitHub, every time that you see this, you can leave a comment and comment and comment. So you can discuss with people about many things.
And if you need to write more about the modification you have made, then not just only the title.
You can, I don't know the length, but you can write, I think, enough things.
But you remain on the title space, or it will be
No, you will see all I think there is a limit to the text, but I don't remember
it's
it.
better to make a small description and a file ready.
No, you can comment it on here.
Down
If you want, you can go here and comment and write here.
okay. All the
And,
modifications.
yeah, and you can write here in Markdown, so you can see the preview. You can edit in full screen. Okay. Now, let's say, for example, they want to get rid of the image. You might think that you delete the image like this, but when you want to do it with Git, it's different. And it's a mix of what I told you before. It's not git add, it's git rm, git remove, and the file name. This is a shortcut because it basically deletes the files for you and add this modification to the index. So if I do this, if I do status, it already tells us that this has been deleted and is already to the index. So now you just have to do git commit -m delete image. Okay, and then you go git push.
When we delete, we don't need to add.
No,
Just automatically to commit.
you just do git rm. It will delete it for you and add it to the index. That's a shortcut. Otherwise, you will. So now we are 6 and there is no image. Okay,
Yeah.
and this was deleted. But if I go here and I go here, there is still the image. Okay, so it's always in the history. I wish the same thing if you want to rename it. It's not move, is git move and the file name and the direction. Okay? Move. Like you will do move in the terminals, here is git move file name where. Because that helps Git understanding what happened with the files. Okay?
If we do it manually, it detects it.
Then it will tell you there is an error, file is missing, so the best way then is to git remove the file and then you fix with that.
And gives the error.
Yeah. Yeah, because it's tracking one file and then it disappeared outside of its reach. And what is this? Okay. One more thing is that you can go back in time, also locally, to the project, not just the file. It's a bit more complicated. It will give you a lot of messages, so you just need to remember 2 commands to say things. For example, I want to go back to the moment when we had the image. Okay, so I copy this. Here you see we don't have the image. The command is git checkout, and I pass this without the file name. If you put the file name, it will just take the file name from that moment in time. Okay? If you don't put the file name, it's going to be completely in that moment in time. Then it will tell you there is a bit of a different situation which we don't want to cover here. Okay, the important thing that you see here that now the file is back again in my file folder. Because Git is basically managing your files. If you want to go back in time, if you want to go back to where you were before, is git checkout master. And then you go back to where you were, not to the last commit, to where you were working. Okay? It's not just the last commit, you were working, okay? I said I just want to go back in time completely for a while. You just git checkout and dash. Then what it tells you that if you want to do modification, you need to create a new branch from that. Okay, but that involves branches we don't want to do at the moment, because if each of you do a branch, then it's going to be a bit complicated at the beginning. The important thing is that if you go back to the master branch, you will go back to where you were before going back in time. So even locally, you can also always go back in time. I will show you one more thing. Let's add a 3D model. If you add an STL, so for example with Blender, okay, I export it as STL, okay, now I have the untitled.stl. If I do git status, I have untitled. Okay, so git add untitled, git commit -m add a 3D model, git push. So it's quite fast when you get to remember all the commands, the sequence. You just add or remove, commit, push. Okay. If I go here, I have a 3D model. Okay. The interesting thing that for STL, which are not too big, you can see them in 3D online. Okay. Even if I go here, if I go here, I will see it here. Before it was green because all the data was added. Now, for example, we'll try to modify this. I will explain then how to modify the things in Blender, don't worry. But for example, I do something like this. I export it, title. If I go here, git status, it has been modified. Git add title, git commit -m modify 3D model, git push. Now if I go here, I don't know why it's having some bugs today, but if I go here, if it doesn't break,
Maybe sometime.
yeah, maybe it's cache. Okay, you see, I don't know why it's saying that this is changed, but maybe the way the data was saved changed it. But you see this part was added. You can also do like this. Okay, this is for simple 3D model, but it's a huge thing that you can do with it. Okay. That's all. So that's the basic that you will probably need. For many file formats, you don't get this nice rendering. So one good trick is that you save a screenshot at the same time. So if you work with Rhino, if you work with AutoCAD, if you work with even with Eagle, any other files, you save a screenshot with the same commit, and then you can compare the different versions. We will then do a bit of practice with that. Okay. Now, this is quite simple because I'm working alone. The problem is if somebody else work with this because they are still working with different versions. There is one simple thing that you need to do, and it's the same happened with Mercurial. When you want to send things to GitHub, it's git push. When you want to download, it's git pull. Everything is updated, okay? In your case, since everybody is working in their own folder, there are no merge conflicts. If there are merge conflicts, call me and I will solve it. Okay? In this case, you always just have to remember that before doing the commit and the push, do the git pull. Always do that. Because if you do commit and push, but you didn't do the git pull before, you will get a conflict. So always do a git pull, always get the latest version, and then you send your one. That's very important. Okay? So in this case, in this case I can delete this in settings. I can delete this. Okay. Now, for example, then one thing that you have in GitHub, you can have organizations of people. In this case, we have OpenDot. These are the history, so somebody already had things. Okay. This is our repository. So you see each of you has a different folder. Okay, that's the same that you will have in the Fab Academy. And well, the README. So you have to work on this, you just do the git pull and so on. If you see here, some people already did some things. Okay? So Victorio created it, I added the folder. You added something?
Yes.
And then Saverio added something more. Okay? So you can also check what's added and so on. So you see.
So, for this one, we don't have, this is page to access.
No, it should be okay like this. With Mercurial for the Fab Academy, yes, that's a bit more complicated. But if we work with that, I will tell you how to do that. But with this, it's pretty simple. It's much simpler to use. Then what happens that I have here, I have Fab Academy in Europe. This is all the European repository. Okay. So what I did was to create a program, which is this, that basically do the git pull, download all your work, update the Mercurial repository, copy all the files from the repository on my computer to there, and edit and do the commit and push for Mercurial. So at least twice per week I will do this. So when I don't do this, if I don't do this, what you do is not going to show up on the website online. Okay, so that's just for managing a bit more what happens with you and then having it online. But if you go directly online, that's not going to be online. So now the first thing that you need to do is copy here.
In order to access this one,
You should already add it to the members of
yeah,
the.
okay.
Now, one thing that you want to be very safe, don't do a git clone inside another git project. Okay? Otherwise you will store the history of the history. So, in this case, you do ls-la. If you don't have the .git folder, you're sure. The other way is do git status, and it will tell you this is not a git repository. Okay, so you're safe. There is no repository there. So then you do git clone, and then you paste your link. And then you enter it, and you start to work it there. Okay. So as the last thing for this video, try to do something. You try to do something, modify something and upload,
Yes.
and then I will show you what does it mean to pull. Just edit the text.
I have to do pull before. I have to do pull before.
Yes. Yes, because Saverio did something more. We saw it on GitHub.
When you make the pull,
Mm-hmm.
inside the folder in how to check. You set the folder in the current folder, you put default folder.
Yeah.
You can change every time you can change the folder and make pull change folder.
The pull is basically just taking the newest versions, the more than one, all the newest version, and download them and merge with your project.
If you're set on a folder and in an empty folder, you make a copy, a physical copy. If you change folder and make another pull, you make another copy.
The pull is for the whole repository, not for the folders of the repository. Okay? So it's not that you just take one file, you take everything that's changed.
And if you make the pull, you are set on the
Even if
folder
you're
you
inside a folder of the project, the pull is for the whole repository. Okay?
But if you have already made a pull, you didn't make.
If you already had made a pull and everything is okay, it will tell you already up to date. So in this case, this is your GitHub repository, which is this one. Okay. If I do git status, everything is okay. Okay, but I see from here that there is a new version. Okay. So now I need to do git pull. Yeah. So there were just one thing inserted and one deleted. So you can see also here. Okay. If you don't do this, then you will get an error. Remember that if you get any error, you can delete everything and do git clone and get all the history. But you get only the history, not what you add in the folder that you didn't add and you didn't commit. So this is the basic for the moment. I will just add one more thing.
So you said that we should clone the whole repository.
Yes.
Not
No.
only our.
No, you cannot.
folder.
Clone is just for the whole project.
Should put the whole.
Yeah. I could have created a repository for each of you, and then I could have merged them for you, but then you don't understand how to work with the other people. Okay, so that's something you did. One more thing.
And another question. This is just that when shall we add emails?
Whenever you think that you say something that you want to save, it's like file save, you just do git add git commit. Okay, maybe you don't want to do thousands of times because then the space will be limited. Another way for working on GitHub is by using issues. Issues is basically like a blog post where you talk with the other people about what's to be done in the repository. So for example, you create a new issue. It's here. You create a new issue. You select here one of these tabs. And for example, just a test. I can assign to one of you. I can assign it to you, and I can write. Okay. I can do also Facebook style. It's Markdown. The nice thing is that if I copy the hash and if I paste it, he already knows to what it refers. So this is something that you can use for talking with me, or you can use for talking with each other, and you can reference things in the history and so on. And then you submit it, and then you comment and comment and comment. When everything is okay, you click on close.
It's possible to set a time in which we have to resolve this issue or something else.
With the milestone. You create milestones, okay? We set like, I don't know, first project or which week project. We set the date, and then when you create the issues, you select the milestone. You select it here. One more thing that's interesting, GitHub has Android and iPhone applications where you can get notification and see everything. So wherever you are, you can get an idea of what's happening. Then when you do everything and like synchronize it with it, you go to fabacademy.org, you go to class archive, courses 2015, students, and here you will have your own things. So for example, I don't think I have synchronized it yet. Let me check. So it's still empty. But for example, I also created in labs. This is the page that I created. It's just HTML in JavaScript and CSS. Okay, so you see it's a map. And here you can get back to your folder. Here's the link to the repository on GitHub, things about me, and so on. So that's basic. So for the moment I will synchronize, so I will help you also overcome this.
Yes.
But then later, ideally, you will have to jump into this.